Hi everyone, my name's Adam. In this problem, what we're going to be doing is finding the function y equals f of t passing through the point 0, 10 for the given differential equation dy dt equals 1/2 t. So we'll start with our differential equation. Dy dt is equal to 1/2 t. Now again, what we're trying to do is find the function y equals f of t, at least in the general form, such that if we took the derivative of it, we get the differential equation dy dt equals 1/2 t. So how do we start with this? Well, starting to solve a differential equation, the first thing we're going to do if you remember, we're going to separate our variables. And by separating our variables, what we mean is we're going to take all terms with either a y and a dy on one side, and all terms with either a t or dt on the other side. So what we have is dy dt, again, equal to 1/2 t. So we can, say, multiply both sides by our differential dt, and seeing on our left-hand side, our dt's will cancel, giving us the equation dy equals 1/2 t dt. And so now to solve this, we integrate both sides. So we're going to take the integral of the left. So the integral of dy is equal to the integral of 1/2 t dt. We'll bring the constant outside, so this is equal to 1/2 times the integral of t dt. So looking at the left, the integral of just dy is actually the integral of the constant 1 dy. So the antiderivative of 1 with respect to y is equal to y. So y is equal to 1/2 times the antiderivative of t is 1/2 t squared. So 1/2 times 1/2 gives us a 1/4 t squared, and plus our general integration constant c. So let's pause here for just a second to make sure we understand what's going on. So if you notice, we didn't put a general integration constant on the left-hand side, we just put it on the right. And why did we do that? Well, there's two ways to doing it. Generally, if you have taken the antiderivative of both sides, you can put the general integration constant just on one side. But behind the scenes, remember what is going on is we do have an integration constant on the left. So if we were to write this out the long way, we'd have something like y plus, say, constant c1 is equal to 1/4 t squared plus some integration constant, say, c2. But what we can do is bring the c1 over to the right-hand side, giving us y equals 1/4 t squared plus c2 minus the constant c1. And a constant minus a constant is, again, just another constant. So we'll just call that the general c. So it's typical just to skip this kind of work and jump into writing it like this, but that's what we mean. Okay, so from here, now we have y equals 1/4 t squared plus c, and the general form of this is y minus 1/4 t squared equals to c, setting the equation equal to our constant c. Or not the general form, but the general solution. So what we want is the particular solution. Our particular solution, say, at the point 0, 10. And what do we do with this? Well, we can use our general solution, plugging in the specific values of y and t. So for y, we have 10 minus 1/4 times t squared, or 0 squared, and that's equal to the value c. So 0 times anything gives us 0, so that just implies that c is equal to 10. So then plugging that specific value back in, and we're going to write it as we say in the directions, y equals f of t. So y on the left is going to be equal to, say, positive 1/4 t squared plus the constant 10. there is our particular solution, y equals f of t, passing through the point 0, 10. Now we're going to use a graphing utility to graph the solution to our differential equation. So we're going to graph the solution, y equals 1/4 t squared plus 10. So we're going to go into our function input, and for our y1 equation, instead of t, we'll be using x, but we have 1/4 t squared, or 1/4 x squared. So we can simply type in x squared divided by 4 plus 10. And we'll set our window. With a little bit of trial and error, I think I found a pretty good window. Will take us from our x min to be -5, our x max to be +5, and our x scale will count by 1. Our y min will go from -5 to y max at +15, and y scale will count by 1. So I'm choosing this window specifically just to get to see that we can show that the graph will go through our particular point at x equals 0, y equals 10. So be inside that range. And now we can just press graph. And so we see as it's being traced out, we can tell from the equation that it should be a parabola, and that's what we see, opening upwards. And if you can count the tick marks, you do see that the equation goes through the point at 0, x value 0, y value 10. But we can confirm this with our trace feature, pressing the trace button, and press x equals 0, and enter. We get a y value of 10, which confirms our graph goes through that point. Thank you very much.